Hi guys. So we are moving into our next chapter. We're going to talk about, in chapter 4, we're going to talk a lot about triangles. Classifying them is our first section. This 4.1, we're going to classify them based on their lengths, based on their angle measurements. So we are classifying triangles. We're also going to talk about the angles of a triangle, be able to talk about that and what they add up to. So pretty basic. We all know that a triangle is a polygon with 3 sides. Okay. And when we talk about the interior angles, we certainly talk about them in regards to triangles, but we can talk about them with any polygon, really. We know the word interior is like inside, like an interior of a house. So the interior angles are, angles on the inside, or angles inside a polygon. Okay, and just like we know interior, we also know exterior. And exterior, if we talk like an exterior of a house, we're talking about outside, so angles outside a polygon. Okay. And then we have this word corollary that we want to define. So a corollary, it's not necessarily a geometric term that we talk about with polygons. It's more of something that would go along with the definition of a theorem or a postulate that we've talked about. It's kind of like one of those rules. A corollary is a statement that can be proved and it usually comes before a theorem. Usually. Okay. So in a theorem, you're given some strict rule. The corollary is just a little bit of that background information that helps you follow that rule. So let's keep going. So then we jump back into the triangles. So in this box here, we are classifying the triangles. We can classify them, as I said, by their side lengths. We can look at their side lengths and classify them that way, or we can classify them by their angle measurements. So if we talk about classifying them by their sides first, a scalene triangle, none of the sides are congruent. So all 3 of these sides will have different lengths, different measurements. An isosceles triangle, you have 2 side lengths that have the same measurement. So 2 side lengths are congruent, and you'll see that when you have these little tick marks here. Okay, that's how you know that side lengths are congruent. And if you have an equilateral triangle, that means all 3 of those sides are the same. Okay, we can also talk about classifying them by angles, by their angle measurements. An acute triangle, all 3 of the angles here are acute. They may not be the same measurement, but they're all less than 90 degrees. A right triangle is going to have a right angle in it, and these 2 angles are going to be acute. An obtuse angle is going to have, an obtuse triangle is going to have 1 obtuse angle. Okay, so this larger angle here, it's bigger than 90 degrees, and then it has these 2 acute angles. And then you have an equiangular triangle. Again, if you know that, if you know certain angles are going to be congruent, you'll know that by these arc marks given to you. Okay, and remember, we have something, if we have an equilateral and an equiangular triangle, at the same time, we call those a regular, right? We can call them regular triangles. So then we look down here at example 1, and I have this triangle. I'm going to call it triangle XYZ. So we call triangles by listing the 3 vertices. We want to classify it by its sides and by its angles. So if I look at it by its sides, these 2 sides here have their tick marks, which means these 2 sides have the same length. And this last side doesn't have a tick mark. So only these 2 sides are the same. So off the bat, I know I have an isosceles triangle. Okay. And then I also notice in the angles, right, I have a right angle here. I have that right angle box, which means my triangle not only is isosceles, it's also a right triangle. On B, I have 3 tick marks on all of my sides, so I know that all 3 of these sides are going to be equal. So I have an equilateral triangle. Okay, and I'm not given the specific measurements of these angles, but you can see in this triangle that all 3 of these angles are less than 90 degrees, right? These are all smaller than a right angle, so I'm going to call this an acute triangle as well. Okay, and then I just have a triangle and it doesn't look like I have any markings on my diagram, right? So this length JK is different from this length KH, which is different from this length JH, right? So all 3 of these sides have different lengths to them. Because they are all different lengths, we call this a scalene triangle. Okay. And if I can look at my angles here, I notice that we have one large angle here, and this looks like it's larger than 90 degrees, right? So this is going to be an obtuse angle, which makes it an obtuse triangle. All right. Then we're going to scroll down here, keep going. So we're going to look at these diagrams and classify these triangles that they're talking about. So again, they're listing the triangle name. They put a triangle symbol before it, and then they list the triangle by listing the 3 vertices of it. So in A, we're looking at triangle EHG, which is this big triangle, this entire triangle. We want to classify it by its angle measurements. So angle E here, right, is 30 degrees. Angle G is 60 degrees. And I see that I have a right angle here. So if I'm classifying it by its angle measures and I see that I have a right angle, that means I have a right triangle. And now I want to look at triangle EFH, which is this smaller triangle to the left. So I know that this angle 30 degrees is the same as this angle 30 degrees. And if I look, right, this looks obtuse, but we could actually find the measurement to prove that it's obtuse. I see I have my straight line right here, and this angle is 60, right? So this 60-degree angle and this larger angle here, these are a linear pair. So I could say that this angle is 120 degrees because they're going to add up to 180. They form that straight line. So although it looked like I have an obtuse angle, right, we were able to prove that I actually do by using what we know about linear pairs. So I can classify this triangle to the left, EFH, as an obtuse triangle. Okay, and then we jump down here to A and B, and we want to now classify by the side lengths. So we're looking at triangle ABC, so we're looking at this triangle here. We see that we have tick marks. So if this side is 15, this side over here with the tick mark is also 15. I also know this last side is 15. So they all have the same exact measurement. They all have a length of 15, which if I want to classify this by a side length, right, that means that these are equilateral, or this is an equilateral triangle. If I want to look at the triangle ABD, okay, this length AB is 15, this length AD is 18, and if I want to talk about this entire length, the BD, I'm just going to add the 15 and 5, right? So BD is going to have a length of 20. Because these 3 lengths are all different, this is going to be a scalene triangle. Okay. And then we can try the next one down below. So it says find the side lengths of the triangle. So on my triangle here, I can't find the side lengths unless I know the value for x. So I first have to find the value of x. In order to do that, again, I see that I have tick marks here, which signifies that this length LK will be the same measurement as JK here. So in order to find the measurement of x, I could set this up as x plus 3.2 is equal to this length 4x minus 1.3. okay? And then I can solve down, I will find x, right, my value for x, and then I can just plug it back in to find these actual side lengths. So I'm going to go ahead, I'm going to subtract the x from both sides. When I do that, I'm just left with 3.2 equals 3x minus 1.3. And then I'm going to add the 1.3 to both sides. I'm going to get 3x equals 4.5. And when I divide by 3, I should end up with x is equal to 1.5. So I'm going to find all my different side lengths here. I'm going to plug in, I'm going to find the length of JL first. Okay, so I would take 5 times my length of x, or my value for x, 5 times 1.5, and then I subtract that 0.2. So 5 times 1.5 will give me 7.5. 7.5 minus 0.2 is going to give me 7.3. So this length here of my triangle is 7.3. I'm going to also plug in, I'm going to find the length of LK, right? We're going to plug the 1.5 in for x. We would say 1.5 plus 3.2, which is equal to 4.7. Okay, because I know that this length is 4.7, I do not necessarily have to plug x in down here to find the length of JK. You can certainly do that to double check to make sure that you solved correctly. But because I have my tick marks here, if this length is 4.7, I know that the length of JK must also be 4.7. Okay. I want you guys to take a second. I want you to pause the video here, and I want you guys to try this guided practice. Try these problems on your own. When you finish and you unpause the video, I'll put up the answers to them and I'll review them quickly. But I do want you guys to try these on your own first and see how you do, okay? So take a second and go ahead and pause the video here. Okay, so going over these answers, in number 1, it says we have triangle JKL, and it's saying that the side JK, the side KL, and the side JL are all equal. Knowing that all the sides are equal lengths, that helps us classify triangle JKL by calling it an equilateral triangle. So all 3 sides are the same, it's equilateral. If I have an obtuse triangle, what that means is, as we said, we have one obtuse angle in there and the other 2 angles have to be acute, okay? On 3, 4, and 5, we're looking at the different triangles. So we're looking at triangle DBC first, so this triangle, the smaller one to the right. And we want to classify it by its angle measurement. So we'll see we have a right angle on triangle DBC, so it's a right triangle. If we look at triangle ABD, we have a right angle here as well. Remember, we're forming a linear pair, so if this angle is 90, this angle must also be 90. So we have a right angle on triangle ABD. And on number 5, I'm looking at this entire triangle ADC here. We'll see that this angle is 59 degrees, this angle is 20, but this angle above here, we add the 31 and the 70, we'll get 101, which means it's larger than 90 degrees. So we have an obtuse angle, which means that this triangle ADC is an obtuse triangle. On number 6, we're looking at triangle EGH, which is this entire triangle here. We see that this has a tick mark with an 8 here, which means this outside side length over here to the left is also 8. And then we have these double tick marks, meaning that this side length is also 3. So the entire bottom side length would be 6. So I have a triangle that has the side lengths of 8, 8, and 6. 2 are the same, so that means we have an isosceles triangle. If I look at triangle EFH, I have a side length of 8. This side length that's really cutting through the big triangle, we have this line telling us that's 7.4. And then we have a length of 3. So we have 3 different lengths, which means we have a scalene triangle. That also goes for the triangle HFG. We have the 7.4, the 8, and the 3 for our side lengths. On number 9, we have all 3 sides being the same. So we have an equilateral triangle here. So we want to go ahead, we want to find the side lengths, but we can't do that until we know what our variable is. We can find our variable. We know that these two sides are equal, so we set them equal to each other and solve. So we take the 6y equals 4y plus 12, we get y equals 6. So to find the side lengths, I just go back and plug them back in. So I say 6 times 6, which is 36, or 4 times 6, which is 24, and then plus 12, I get 36, so I know I'm correct here. On this next one, I have two side lengths that are the same, so I have an isosceles triangle, but again, I can't figure out what the side lengths are going to be unless I know what x is. So I'm going to set these equal to each other because I know they're congruent, and I'm going to solve for my value of x, and I got that x is equal to 0.7. Once I have that value for x, I'm going to plug that back into these equations and get my side length. So I plugged it into this one. I know that this is going to be 3.1. We don't necessarily have to plug it into this other side length because I automatically know that this side length must also be 3.1. But I do want to plug it into this last one because it's a different length. So when we do that, we should get 3.3 for that last side length. Okay. So moving on, we have a couple of theorems here. So the triangle sum theorem talks about the interior angles of a triangle. So we can say that the sum of the interior angles of a triangle is 180 degrees. So all those inside angles, those three inside angles on my triangle, they all add up together and they're all going to add up to 180 degrees. Okay. The exterior angle theorem, in words, it sounds a little messy, but we're going to see it goes along with a couple of the examples below. So I'm going to write it out in words and then I can explain it below. So the exterior angle theorem says the measure of an exterior angle of a triangle, and I'm just going to draw a triangle to say that. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay. Again, I'm going to be able, that goes with B down here, so I can talk a little bit about it more down here. And then I just have a corollary. As I said, a corollary usually leads into a theorem. So it technically should have been above the triangle sum theorem, but it's just a little bit of background information, kind of like a side note to that theorem. So acute angles, or the acute angles of a right triangle, are going to be complementary. Okay, and we learned that the word complementary means that they add up to 90 degrees. So if you think about this, right, using the information that we know from the triangle sum theorem, if I picture a right triangle here, right, then I have a right angle. Automatically, I have to deduct this 90 degrees from the 180, right, to figure out what these other two angles are. And I'm only left with 90 degrees to play with for these two angles to add up to, okay? So that's what we're saying, this angle X and this angle Y, they have to add up to 90 degrees because there's another 90 degrees being taken by this right angle here, okay? So in letter A, we want to find the value of X, then we want to classify the triangle by its angles. So we see on letter A, we have our three angles here. What we had said in the triangle sum theorem is that we can add all of these together to get 180. So I say x plus 3x plus 60 equals 180, which is just 4x plus 60 equals 180. So we can go through, we can solve for x, subtract 60, we get 4x equals 120. When we divide, we get x is equal to 30. So I want to go back. We found the value of x, but I also want to classify the triangle by its angles, which means I need to know what these angles actually are measured at. So we know this angle x will be 30 degrees. And if this is 3x, we know that this angle up here will be 90, which means this is actually a right angle. So we have a right triangle. Okay. And I had said B goes along with our exterior angle sum theorem. Or sorry, just the exterior angle theorem. So it says the measure of an exterior angle of a triangle. That would be this angle x. So we're saying the measurement of x is equal to the sum of the measures of the two non-adjacent interior angles. So we're looking at these two angles here. These are inside my triangle, so they are interior, and they're not adjacent to this exterior. So I'm looking at the two interior angles that are not sitting directly next to or are not attached directly to this angle x here. Okay, and what the exterior angle theorem says is x is going to be equal to these two angles added together. So x will equal 64 plus 70, which will mean x is equal to 134. Okay. So if this angle is 134, we could find what this last interior angle is just so we can classify the triangle. We would do 180 minus 134, which is going to give us that this angle here is 44 degrees. Okay. Because all of these angles are less than 90, that means that this is an acute triangle. Okay. Scrolling down, we want to do a little bit more here on our examples. So again, we have this exterior angle sum theorem. So this is my exterior angle, which means it's going to be equal to the sum of these two angles. So we would say x plus 45 is equal to our exterior angle 2x minus 2. Okay, then we can go ahead and solve. We subtract the x, we get 45 equals x minus 2. We can add 2, we'll get x is equal to 47. Okay, so we do want to go ahead, we want to find the measurement of this exterior angle. So we would take 2 times 47 minus 2. That's going to give us, let's see, that's going to give us 94 minus 2. That's going to give us that this angle out here is 92 degrees. Okay. B is a little bit different because I need to go ahead and first off basically figure out what x is, because I can add these two angles together, but I don't have anything to set them equal to over here. So I want to figure out what x is. I know that in a right triangle, these smaller angles, these acute angles, they have to be equal to 90 degrees. They have to add up to 90 degrees. So I'm first going to solve for that x by saying 3x plus 2 plus x is equal to 90 degrees. We can add this. We say 4x plus 2 equals 90. Subtract your 2, you'll get 4x equals 88. And when you divide, you should get x is equal to 22. Okay. Again, we weren't able to go through this process because there was no variable here. I could have plugged in, we could have called this maybe 180 minus x because we have a linear pair here. But we could have just as easily done it the same way here where we solve for x first. And then once we do that, we can use our exterior angle sum theorem, or we can just take the fact that this is a linear pair. So here I could say 180 minus 22 to find your exterior angle out here, which means that angle 1, I'm just going to call it that, is equal to 158 degrees. Okay. So go ahead again and pause this video try these three problems, 11, 12, and 13. You can try those. And also on the next page, you can try 14, 15, and 16. Try these 6 problems on your own. Again, you'll pause it, and when you unpause it, I will put the answers back up and we can go over them quickly. Okay, so going back up here to 13, 11, 12, and 13. So on 11, I have a right angle here. Remember in our corollary says the acute angles of a right triangle have to be complementary. So, so we can set this equal. We can say x plus 2x equals 90, solve down, and then we can plug that number back in for x, get these angle measurements. We automatically know already because there's a right angle here that we have a right triangle. On 12, we use the angle sum theorem. We know that all 3 of these angles, when we add them together, we'll get 180 degrees. So we add them all up to get our value for x. Once I have my value for x, I go back in and I plug that in to get my values for these missing angles. And because they are all less than 90 degrees, we have an acute triangle here. Over here, we use the exterior angle theorem, which we said was these 2 angles added together will give me this exterior angle. So we say 50 plus 70 equals x, which means x is 120 degrees. So this outside angle over here is 120. We still want to classify our triangle, so I found this missing angle, this missing interior angle, by doing 120, which was our x, minus, or 180 minus 120 to get the 60 degrees. So because all of these angles are also less than 90 degrees, again, we have an acute triangle. Going on to the next page, I again want to find the exterior angle shown. So we add up 80 plus x, and that's going to equal this exterior angle of 3x minus 22. So we can go ahead and solve. We get x is equal to 51, and it asks us, we want to find the measurement of the exterior angle shown. So this exterior angle, when I plug that 51 in for x, will be 131 degrees. On 15, we add up the 2x plus 3 and the 51. That's going to equal 4x plus 8. And then we can go ahead again and solve. We get x is equal to 23. Plug that in here. We'll get this exterior angle is 100 degrees. On 16, again, we're using our exterior angles. We add these 2 angles together. So we're always adding the interior angles. And we say that will be equal to our exterior angle of the 6x minus 7. We can go down again, solve for x to get x is equal to 22. And then we can go ahead, plug it in to get this exterior angle measurement. Okay. And then the very end of these notes, as we had said, we talked about a corollary. We talked about this corollary, the right angles or the acute angles of our right triangle being complementary. We already discussed that. What we didn't get to talk about is the measurement of each angle of an equiangular triangle is 60 degrees. So if you think about an equiangular triangle, all of these angles are equal. So let's say all of these angles have a measurement of x degrees. Okay, we already know from the angle sum theorem that if I add all of these together, we'll add up to 180 degrees. So we set that equal to 180. So over here, if we have x plus x plus x, we have 3x plus 180. And when we divide that, we get that x is equal to 60. So that's why every single angle, every interior angle on an equiangular triangle is always going to be 60 degrees. Okay, and that is it for these notes for section 4.1. If you guys have finished these notes before class is up, go ahead and get started on the worksheet that is in your packet on 4.1.